So today we're going to be looking at a pig's heart, and we're going to be looking at all the components that make up how this muscly organ works to pump blood around the body. We're using a pig's heart because it's relatively similar in size to an average human heart, which is about the same as your fist. So if we look at this muscly organ, we can see that there are a number of blood vessels coming out of the surface. We're going to be cutting open into the 4 different chambers of the heart to look at what each section does. Now, if we look at the outside of the heart, we can see just where the top surface lies is where the atria would have been. These have been trimmed off so that we can see the details of the inner cavity. So we're going to make our first incision onto this side of the heart, parallel to the coronary artery. Now, the coronary artery is the main blood supply to the heart tissue itself, so the heart has its own supply of oxygen and glucose. When we make this incision in here, we're going to be cutting into the most muscular part of the heart, which is the left ventricle. And the left side pumps blood around the entire body out of the blood vessel called the aorta. So our first incision will be parallel to the coronary artery, straight through the muscle. You can see as you start to cut it open, it's thick muscle tissue, so it may need more than one cut. And you can see the depth of the ventricle there. Incredibly thick, firm, muscular piece of tissue. Now if we take our scissors and we continue that incision straight up to the top of the heart, and we go into the remainder of the atrium. And we see once we cut this ventricle open, the cavity on the inside and the sheer depth of the muscle tissue. We can also see, if we clean away some of the remaining debris, the tenderness heart cords. Now these are there to attach the heart valve to the tissue of the muscle. And those heart valves are incredibly important in maintaining unidirectional flow of blood around the body. The second incision we're going to make is going to be into the right ventricle. And again, take the scissors to cut up towards the atria. And in there we can see the right ventricle of the heart, much slimmer muscle wall, because the right side of the heart is only pumping blood to the lungs. So the blood is pumped under much lower pressure. So if we go back to the blood vessels that we can see at the top of the heart, we can use a seeker or a finger to put a finger down the vessel to see where the chamber ends. So if we go down this blood vessel, it comes out into the left ventricle, the thick, chunky ventricle. So that must be our aorta that's going to pump blood around the entire body. If we were to explore the other blood vessel, which is much thinner, it goes straight into the right ventricle, the thinner, less muscular ventricle. So that must be the pulmonary artery that's going to transport blood from the heart to the lungs. Now, in order to stop blood flowing back into the atria, each of these ventricles have a valve. Valves are there to stop backflow of blood and to maintain unidirectional blood flow. Sometimes there are heart problems that mean the valves don't work properly. They either don't revert back to their original shape or they become loose, and we can replace those valves either biologically or mechanically. If we look back at the surface of the heart with the coronary artery, a common defect that you might see here is coronary heart disease. And that's when these arteries become blocked with layers of fatty deposits. Now, in order to treat that medical condition, you can have a stent put in, which keeps that artery open and maintains blood supply to your heart. So in order for your heart to pump the blood around the body, you need to maintain that heart rate. And resting heart rate is maintained by a little bunch of cells in the right atria that signals when the heart needs to beat. Now, if you need to increase your heart rate because your body needs more oxygen or more glucose, then adrenaline is released from your adrenal glands, It's what causes that fight or flight reaction, and it will increase your heart rate to provide more oxygen and glucose to your body. If you'd like to know more about heart dissections, then see our website for lesson plans and risk assessments. Thank you for watching.